So up on top we have some key vocabulary words that you're going to need to know. I believe quite a few of these were on your vocab sheet. So a mathematical quantity is anything that can be measured or counted. Some quantities remain constant, others change or vary, and they're called variable quantities. Numerical expression. You guys have known numerical expressions for a while. It's a mathematical phrase involving numbers and operations, but absolutely no symbols. So for example, 2 plus 3 minus 7. That is a numerical expression because all I have in there are numbers. That's where the numerical part comes in. Simplify. We always need to simplify. We are not always told to simplify. It's one of those unwritten rules that you need to remember. So when you're given, for example, a numerical expression like this, you need to remember you have to simplify it, which means actually add and subtract. My example here, I had 2 times 8. I can't leave that as a final answer. I need to simplify that by actually multiplying 2 times 8. So then we have a power, has 2 parts. It has a base and an exponent. So for example, 3 squared. 3 would be my base because that's the number that has an exponent attached to it. And 2, obviously that's my exponent. You guys know exponents pretty well. Now a couple of things that happen. If I have a -3 and I'm squaring it, and my -3 is in parentheses. If you remember, your exponent means you're taking that and you're multiplying it twice. So -3 squared means it's -3 times -3. So that's going to end up being a positive 9 because negative times negative gives us a positive. However, if there are no parentheses, this means the only thing that's being squared is the number 3. The negative sign is not being squared. So that's why I have over here negative and then 3 times 3. Well, 3 times 3 gives me 9, but I've got that negative in front, so that gives me a -9. And I know a lot of kids tell me, well, that's not really a big deal, but it actually is. Would you rather have $9 or -9? I'd rather have 9. So that negative sign changes the answer completely. And then the other thing for us to take note of right here, anything to the 0 power always equals a what? Does anybody remember?
1.
Bradley? 1. Anything to the 0 power is a 1. I could have 1 million to the 0 power. It's going to equal 1. I could have parentheses and then have this whole big thing like that to the 0 power. That all turns into a 1. Anything to the 0 power is a 1. So those are all things we want to keep in mind as we go down here and follow our order of operations. So who remembers order of operations? Athena. Perfect. So our P is our parentheses. Now the thing with parentheses is there's a lot of different actual symbols that fall under the parentheses category. You have actual parentheses like you guys are used to seeing. They're around points on a graph. They're around other things that we're going to talk about. Then they also have brackets, which those count as parentheses. So they would happen in the parentheses step. And then the other thing that happens in the parentheses step are your absolute value. If you have absolute value bars, it's treated just like if it were a parenthesis. And then, yeah, so we have exponents. And then we have multiply, divide, and then add, subtract. Now remember, multiply, divide, I wrote those together because they really happen at the same time. It's just whichever one you see as you go left to right through your problem happens first. Same thing with add, subtract. They really happen at the same time, but whichever one you see first looking left to right is what you do first. So let's take a look at our first example we have here. Number 1. Do we have parentheses? We actually have two sets of parentheses, don't we? We got these nice little brackets here, and then we've got these parentheses here. So which one do you think we're going to do first? Perfect, the ones on the inside. So 3 minus 1 gives us a what? So this would be a 2 to the third power. I'm going to write it right there. Does anybody know off the top of their head what is 2 to the third power? Oh, so good. So this 2 to the third turns into an 8. And I'm just going to bring everything else back down around it. So I brought down my plus 6, my brackets, my 2/7 and my 5. So now we're still working in the brackets. So now we need to add, what's our 6 plus our 8? 14. So we get 5 plus 2/7 times 14. And I just kind of gave you a hint. Which one are we going to do first? Are we going to add with the 5 or are we going to multiply here? Perfect. So go ahead and use your calculator if you need to. We're going to multiply 2/7 times 14. Make sure you put parentheses around your 2/7. What's that? So hopefully everyone got a 4 when we typed it in. So then our last step, 5 plus 4, we get a final answer of 9. So my little bubble in there tells us what you want to do is you want to try to compare and contrast problems. That's a skill you want to try to learn as you're going through and you're looking at your notes to try to help you do your homework also. So what's the same about my two problems that I have here? There's parentheses in both of them. Anything else? They all got numbers, right? Both got numbers. We got some adding, some multiplying. But what's the big main difference that you probably see right away? We got a fraction, right? Everybody's like, oh my God, fractions. But fractions are our friends. They both start with FR. So with a fraction, what you want to do is you want to take care of the top and get that down to a single number, simplify that to one number. Take care of the bottom, simplify that to one number, and then you do your division afterwards. So if we look at just our numerator, what do we want to do first? No. Add what's in the parentheses first. So 3 plus 1 gives us a 4. So we got 7 times 4 minus 2. What do we want to do first in our denominator? Multiply. So 5 times 2 gives us a 10, and then we have our plus 3. Okay, next step. What do we want to do next in our numerator? We could probably actually do these two steps at once. If we multiply 7 times 4, what do we get? Minus 2, 26. And then our denominator, 10 plus 3, 13. So when we actually divide, we get a 2. 26 divided by 13 equals 2. So you guys know these operations, but sometimes you forget them when you're working on the problems because you're just trying to go so fast because you just want to get your work done. So just make sure you take your time and you move slowly, and you guys will be able to get it correct. So if we take a look at the back, we're going to talk about algebraic expressions now. So we had numerical expressions on the first page. That's using our order of operations. You simplify it down to one number. All you have are numbers. Algebraic expression means now you have some letters in there. You have some variables. So like 2x plus 3. That would be an algebraic expression now because I added the x in there. I could use other letters. Let's see here. I could have a squared b to the third. That's an algebraic expression because there's letters in there now. So that's the difference between the numerical ones and the algebraic ones. We all know a variable. Variable is a symbol that we use when we don't actually know what the number is, so we just put it in there. We could use a smiley face instead of a letter, but New York State prefers us to use letters, so that's what we use. In an algebraic expression, a term can be a number, variable, or the product of a number or variable. And you can have more than one variables in there. So x squared y plus 3. I have 2 terms in here. What are my 2 terms? Bradley? The x squared y is 1 term. What's my second term? The 3. The thing that separates your terms in this example is your plus sign. Plus sign, minus sign, that's what separates our terms. So I have 2 terms there. I could simply have another one that's like x plus y plus 1. So this one has 3 terms. The x, the y, and the 1. So you can have multiple terms, you can have 1 term. Doesn't matter what makes up the terms. The coefficient is the number that comes in front of your variable. So if I have 4x, that 4 is my coefficient because it came in front of my variable. And we always write our coefficients in front of our variable. So if we look at this example here, 3x squared. What is our coefficient in that example? The 3. What's our base? The x, because the 2 is the what? Exponent. The 2 is up there in your exponent spot. So your x is your base this time. And then our exponent is a 2. And then you evaluate an algebraic expression because they tell you a number to plug in for your letter. And then you follow your order of operations like we were doing up on the front page. So if we take a look at our first example, we're given x squared minus 5x plus 4. What do they want us to plug in for x? A 7, because they tell us x equals 7. So you really want to use parentheses when you go to plug in any number for your variables. So as you can see up here, my x squared, I did parentheses 7, and then I squared it. And then minus 5 instead of x, 5 times 7. Again, I use my parentheses and plus 4. And then once you plug it in, it's just like we were doing on our front. Order of operations. Do we have any parentheses to distribute through? I mean, yes, we have these ones, so okay, we can multiply. But what should we do with the 7 squared? Should we actually square that? Yeah, what do we get? 49 minus 5 times 7 would give us 35. And then plus our 4. So then now let's subtract and add going across left to right. So 49 minus 35. What does that give us? Say louder. 14. And then plus 4? 18. Bam, that one's done. So let's look example number 2. What are we plugging in for r? Negative 3. And then s, we're plugging in a 9. So we have a negative sign in front of our r squared. So I'm going to put that negative sign there. And then again, when I plug in that negative 3 for the r, I'm putting it in parentheses. So you have negative parentheses, negative 3 squared. And then we have next to it the square root of 9. So I'm plugging in my 9 for my s. Okay, so we don't have any parentheses to distribute. We have nothing to multiply through. We have an exponent though, so what is negative 3 squared? Not negative 9. You didn't use parentheses. Positive 9. But the negative we have here is what turns it back into negative 9. So I think you probably just did both steps at once. So then next we have the square root of 9. Does anybody know what the square root of 9 is off the top of their head? Yes, good job. Now, what are these two things up here doing? Are they adding? Are they multiplying, dividing? These are being multiplied. When two things are next to each other, remember that means that they're being multiplied. They don't always put that multiplication dot in there though. So I simplified this to -9, and it's going to be times the 3 that I get when I take the square root of 9. So then we multiply. What's our final answer? -27. All right, so I'm going to give you guys a couple minutes. I want you to try number 3 and 4 on your own. For 3, you're plugging in a 5 for x, a 2 for y, and then 4, you got to plug in 3 different variables. So be careful on that one. Let's see how we did on these. So for number 3, I saw a lot of you using your parentheses, which is awesome. So we don't have any parentheses to distribute through, so this one we did our exponents first. So it'd be 25 plus 5 minus 12 divided by 4. So then if you look through the problem, I have an add, a subtract, and a divide. So order of operations tells us division is going to happen first. So this becomes 25 plus 5 minus 3. 12 divided by 4 gives us 3. So then we add 25 plus 5 is 30 minus 3 gives us 27. Anybody get 27 right off the bat? A couple people, all right. Did you have a question, Joe? Joe? All right, did you guys try number 4? Yeah? Okay, let's see how we did. So remember, these are absolute value bars. So we go plug in, we have -5 times 2 minus the absolute value of -1. When I actually go through and write my absolute value bars, I have a tendency to over-exaggerate them so that you know they're not ones, that they're absolute value bars. So I need to multiply inside here first. So that gives me a -10. And then the other one's still an absolute value of -1. Does anybody remember how to do absolute value in their head without using the calculator? Yep, you just make it positive. Absolute value just means you take the number and make it positive because you're trying to figure out what is your distance from 0. So -10 turns into +10. So it becomes 3 times 10 minus absolute value of -1 is +1. So now I'm going to multiply. 3 times 10 is 30 minus 1 gives us a final answer of 29 for that one. Okay.